In this video, we will solve this initial value problem. As always, let's start by computing the Laplace transform on the left and the Laplace transform on the right. The Laplace transform of the derivative of a function is s times the Laplace transform of y minus y of 0 minus 7 minus the Laplace transform of y equal to the Laplace transform of 4 times u2 of t times sine of 3 t minus 2 and this. And to compute this Laplace transform, we use this formula. Notice that in this case, we're going to have an e to the negative a to the negative 2s, and this is the Laplace transform of the original function. If this is my u2 shifting function, what is the original function? We forget about the Heaviside function, and anytime we see that t, we replace it with t plus 2. That means that this just becomes 3t, and then we get 4 times sine of 3t. But remember, the Laplace transform of sine of omega t is omega over s squared plus omega squared. Then we can say that s minus 1 Laplace transform of y, right, this part, I'm going to move this 7 to the right, is equal to 7 plus e to the negative 2s, and the Laplace transform of this is 4 times omega, in this case is 3, then 12 times 4 times 3 over s squared plus omega squared, which is 9. And then we solve for the Laplace transform of y by dividing by s minus 1. Then we have this over s minus 1, and here we have s minus 1. Then we want to find the Laplace transform inverse of this, which is easy, and the Laplace transform inverse of this part, so that we can use this formula from right to left. Let's rewrite that expression. We have that 12 over s squared plus 9 times s minus 1 using partial fractions. This polynomial of order 2 is irreducible, s squared plus 9. When you think about the equation s squared plus 9 equals 0, you see that that equation doesn't have a solution in the real numbers, which means that you cannot factor it, and therefore you can proceed with the partial fraction decomposition. You can write this as s minus 1, and on top of an irreducible quadratic, you need to write down a generic linear term. Remember that you have to use different constants a, b, and c. There are as many unknowns as the degree of the denominator. This is degree 3. Then we proceed, we do the algebra. This is a times s squared plus 9 plus parentheses bs plus c times s minus 1 over s minus 1 times s squared plus 9. And then we find the coefficients. We're going to have the most is order 2. What is the coefficient of s squared here? We get this contribution here. We have an a plus b. The coefficient of s squared on the left is 0. The coefficient of s, how do we get the coefficient of s? We get, here we will get that this is c, we have a c, right, because of this, cs minus bs minus b, and there is no s here, then we have 0. And the constant coefficient, we have here 9a, and then minus c. And we want that to be equal to 12. From this system, we have that c equal b, and then these two equations reduces to a plus b equals 0, and this one becomes 9a minus b equals 12. We can solve the equation by adding the two equations. If we add the two equations, we get that 10a equals 12, and that means that a is 12 over 10, which is 6 over 5. And then from this equation, b is negative 6 over 5, and we also know that b is equal to c. We have the solution of the equation here, and that means that this part, forget about all of this, a is 6 over 5, and b is negative 6 over 5, and c is also negative 6 over 5. This part here, let's rewrite it. This is 6 over 5 times 1 over s minus 1. And here we have minus 6 over 5 times s over s squared plus 9. And here we have minus 6 over 5 times 1 over s squared plus 9. But we know that the Laplace transform of cosine of omega t is just s over s squared plus omega squared, and the Laplace transform of sine of omega t is just omega over s squared plus omega squared. We have these two formulas. We need to rewrite this. Notice that this part is ready. This part s over s squared plus 9 is the Laplace transform of cosine of 3t, but this part is not ready yet. We have s squared plus omega squared. That means that omega is 3. That means that we need to have a 3 here instead of a 1. How do we write that? This 6, I can write it as 3 times 2, right? And then we are ready to write it as the Laplace transform. And then that means that this is the Laplace transform of 6 over 5 e to the t minus 6 over 5 cosine of 3t minus 2 over 5, and this part is the Laplace transform of sine of 3t. Therefore, this is this Laplace transform, and using this formula from right to left, we get that the Laplace transform of y is the Laplace transform of 7e to the t plus this part is going to produce a ua, u2 of t times, and instead this is my original function. I have to do the ua shifting. The ua shifting is achieved by changing the t by t minus a. In this case we will have 6 over 5 e to the t minus 2 minus 6 over 5 cosine of 3 times t minus 2 minus 2 over 5 sine of 3 times t minus 2. That means that the answer of the initial value problem is y equals 7e to the t plus u2 of t times 6 over 5 e to the t minus 2 minus 6 over 5 cosine of 3 times t minus 2 minus 2 over 5 sine of 3 times t minus 2. Okay, this is the solution of the initial value problem. As always, this part we have to compute two Laplace transform inverse, one for this part that produced this, and one for this part that give us the f of t that we change into this part of the solution. Okay, this is it for this video.